Hello! For our SciFest project, we decided to examine the potential of liposome technology in the future of transdermal drug delivery systems, or TDDS. In case you're unfamiliar, a transdermal patch is an adhesive patch that attaches to your skin and contains medication. This medication is then gradually absorbed throughout the day. Through this project, we also researched the basics of liposomes and how they perform in TDD.
A liposome is a spherical-shaped vessel which can be loaded up with medicines and used as a drug delivery vehicle for administration of nutrients and other pharmaceutical drugs such as lipid nanoparticles in mRNA vaccines and DNA vaccines. They can also then deliver medicinal drugs to a specific target within the body, such as anti-cancer treatment targeting cancer tumours.
For our project, we wanted to research liposomes' full potential in the field of medicine. However, due to liposomes being more complex to produce and requiring a range of equipment and resources that we did not currently have available to us, we had to adjust our project to suit us.
When researching liposomes, we noticed their similarity in structure to micelles. After researching further, we noticed there have been cases where micelles have been used in drug delivery systems. Finally, we decided to conduct our own experiment to determine the critical micelle concentration, or the point at which micelles are formed, of their surfactant, sodium dodecasulfate. In addition, we examined the effect different temperatures and the presence of the electrolyte sodium chloride has on this value, as these are both key factors present in the human body.
Our hypothesis is that the critical micelle concentration, CMC, of sodium dodecyl sulfate, SDS, varies in increase in temperature and in salinity in the solution. To evaluate this, we examined the CMC at a range of temperatures and a range of saline solutions.
We conducted this experiment using a 10 ml distilled water solution, adding 10% sodium dodecasulfate in a series of 1 drop at a time, recording the conductivity after each drop. Then, using the same process, we heated the water to temperatures 30 degrees Celsius, 40 degrees Celsius and 50 degrees Celsius, analysing the impact this increase in temperature had on the critical micelle concentration. Next, we produced a 0.001 molar saline solution and a 0.0005 molar saline solution, and added 10% sodium dodecasulfate to this solution, analysing the impact that electrolytes have on the critical micelle concentration. After graphing our results and analysing all our data, we conclude that from our research, the increase in temperature and the presence of electrolytes sped up the process slightly, but in the bigger picture made little difference. This information is good as it indicates to us that according to our research, the increased body temperature of 37 degrees Celsius and the presence of various electrolytes in the body does not affect the rate at which micelles are formed.
The future implications for our project are vast. We believe both micelles and liposomes could be used more often to contain medications suitable for transdermal delivery. The transdermal patch is a much more attractive alternative than the stereotypical, stubborn, hard to swallow pills we take nowadays. This could be useful for the elderly, cognitively incapacitated adults and children who find it difficult to swallow chunky pills and may be taking multiple medications daily. This could ease some of their hassle for them simply by applying a transdermal patch in the morning and letting the medication transmit gradually throughout the day, therefore not having to worry about taking further medication later that day. Transdermal patches could also provide an alternative to those who suffer from trypanophobia, or fear of needles. This includes 20% of the world's population who suffer from a mild degree of needle phobia and 10% who suffer from trypanophobia. This is prevalent in today's time with the impending worldwide mass vaccination program.
There are many aspects of our research we plan to extend in the future. We plan to develop the experiments we conducted, making our results more reliable by using an insulated container when testing the increased temperatures, and we would also like to increase the concentration of the saline solution. Initially, we set out to investigate the possibilities of liposomes and their applications into medical technology. Although the course of our project changed, I believe it took a turn for the good. We both thoroughly enjoy conducting these experiments and are fascinated to learn more. We hope that over the coming months, as restrictions are eased, we will be able to gain access to laboratories and the required equipment to start testing with liposomes. We hope to perform an experiment in which we will produce our own liposomes. If we can do this experiment, it will give us a chance to look at the different types of liposomes, the manufacturing process for each of these liposomes, how medication is enclosed in liposomes, and how medication is transmitted. This will allow us to investigate liposomes' ability to administer the coronavirus vaccine. We hope you enjoyed this short snippet of the work we've been doing over the past few weeks, and hopefully you find it as fascinating as we do. Thank you for watching.